Good morning, everyone. Today we are going to talk about angle relationships. So the first type of angle relationship we're going to talk about is adjacent angles. Sorry. Adjacent angles are two coplanar angles with a common side, a common vertex, and no common interior points. So this would be their common side, their common vertex. The adjacent angle would be this one and this one. So angle ABC and angle CBD, those are adjacent angles. Adjacent angles are just next to each other. Okay, adjacent just means next to. You'll notice I use two different marks here because they're not necessarily congruent. Vertical angles are two angles whose sides are opposite rays. They share a vertex, but no side. The vertical angles are always congruent. So when I say there are two angles whose sides are opposite rays, that means this is a vertical angle and so is this. This side right here of this, so if I'm just looking at this angle, this is a side. It has a opposite ray with this. So this should always go into the other vertical angle. In a picture like this, that's not something you necessarily need to think about. But when there's a lot of different angles, which we'll get to in a minute, you have to think about that. Another set of vertical angles is also right here. Okay, so they share a vertex. They're right across from each other. They are congruent. That's very important. They're equal to each other. So one example here could be angle DAC and angle BAE. So that letter in the middle should always be the same. Next, we have complementary angles. Those are two angles that add up to be 90 degrees. Okay, they don't have to be adjacent, but sometimes they are. Supplementary angles are two angles whose measures have a sum of 180. Each angle is called the supplement of the other. Same with here, it's called the complement of the other. Same thing. They do not have to be adjacent. They can be together or apart, but they add to be 180 always. Sorry, I'm always blowing my nose in your ear. I'm the worst. All right. Linear pair is super similar to a supplementary. The major difference is that it's always adjacent. And it also adds to be 180, so that's what it has in common with the supplementary. But the difference is that it's always adjacent. Supplementary, it could be two angles separated. But with a linear pair, they're always together, adjacent like this. Linear pair and supplementary angles, they always form a straight angle or line. And that's the 180 degrees is a straight line. All right. Moving on to some examples here of naming the pairs. So I have to look at this picture and name two acute vertical angles. So we talked about the word acute last class. So that means that the angle is less than 90 degrees. One thing I need to add to this picture before we start is that this is a 90-degree angle. It should be printed in the picture, but it's not. Because you really can't assume things like that. But in order to answer one of the questions, that has to be a right angle. So I'm going to label that for you. Name two acute vertical angles. So let's just go ahead and look for vertical angles. I could call these vertical angles. Okay, this side goes straight into that side. This side goes straight into that side. It's very easy to mix this up and think that it's this angle. That's where it's important for you guys to remember the ray thing. This goes into this one. This goes into that one. That makes these the vertical angles. This side, if I kept drawing it, would go over here. So that can't be part of the vertical angle. Okay. These are acute. They're less than 90. You especially know that because this is 90 here. So I'm going to name this angle EKH and FKG. Okay. So those are two of acute vertical angles. Two obtuse vertical angles. I'm trying to look for two angles that are larger than 90 degrees. Obtuse means bigger than 90, but less than 180. And I'm looking for vertical angles. So I think these could work. They look like they're wider than 90, and they're also vertical. They're opposite each other. So EKF and angle GKH. You could also, just to be clear, say HKG. You couldn't switch it around as long as the K is in the middle. Name a linear pair. Now, there are a lot of linear pairs in this picture. I'm just going to name one. You really just need to find any straight line and name the two angles on that line. So I'm just looking at this one. I got HKE and EKF. So angle HKE and angle EKF. Name two acute adjacent angles. So less than 90 and they're next to each other. I would say you could do either these two or these two. Okay, we know that it's less than 90 because this is 90 together. And they're next to each other. So I'll just do this one, FKG and angle GKJ. Name an angle complementary to EKH. And this one's tough. The answer to this one is angle GKJ. And the reason that it is the answer is because while there's nothing directly next to this adding to 90, this angle is congruent to this one because they are vertical angles. And this one is complementary with this one because you see here that they combine to be 90 degrees. So complementary means they add to be 90. These are equal. And this one adds with this one to be 90. So therefore, this one also could add with this one to be 90. Name an angle supplementary to FKG. Now you could look at it this way, at this straight line, FKG, so this one could add to be supplementary. You could also look at it this way, FKG, and say GKH adds to be supplementary. Whatever one you want, I'm going to go with EKF. But you could also put angle GKH. All right, now they're going to give us a number. What if EKH is 78 degrees? What does that make angle FKG? Well, they're vertical angles, so they should be congruent. What about EKF? EKF. Okay, well, if I cover up part of this picture, these are on a straight line together. They are supplementary. They are a linear pair, so they should add to 180. So in order to find this one, I'm just going to do 180 minus 78. That gives me 102. So this would be 102 degrees. Okay, and if I'm going a little fast, please take the time to pause and think about what I'm saying. I have to go a little fast because I can only record a certain amount of minutes. This next picture, they're asking us to label some stuff. So PQT is 3x plus 47. SQR is 6x minus 25. So we've labeled a picture. We now have to think, what is the relationship in this picture? These are vertical angles. Okay, so that means they're congruent. So I can go ahead and set these two expressions equal to each other and solve for x. So I'm going to subtract 3x. I'm going to add 25. I get 72 equals 3x. If I divide by 3 on both sides, I get that x is 24. That doesn't answer my question. They want me to find SQR. So now I'm going to take angle SQR is equal to, they gave us the expression 6x minus 25. I'm going to plug in my 24 for x and solve, and 6 times 24 gives me 144. Minus 25 gives me 119 degrees. We're talking about an angle. This next picture, I'm not sure if it's the way I printed it or if it's the actual document, but there should be a C here and a B here, and this should have right there. DCB is a right angle. That's why I added that. They tell me that DCB is a right angle, but they didn't have C and B. I don't know if that's the picture or the way I printed it. Then they give us some stuff to label. DCE is 7x plus 2. ECB is x plus 8. Find the measure of DCE. First, we got to find x before we can do that. These two angles they're complementary. They should add to 90. We know that because they told us this is a right angle, and I've labeled it. So I'm going to do 7x plus 2 plus x plus 8 should equal 90. I'm going to combine my like terms. I get 8x plus 10 equals 90. So I added these two, and I added 2 and 8. And then I'm going to subtract 10 from both sides, and I get 8x equals 80, which makes x 10. I then still have to find the measure of angle DCE, which they told me was 7x plus 2. So I'm going to go ahead and plug that 10 in for x. I get 70 plus 2, which is 72 degrees for my final answer. All right, I'm going to flip it over to the last problem. This problem is the beef. This problem is tricky, but you will see problems like this. The key here is the problem right now is you have two different variables. You have to find x and y. We have two expressions with x in it, so I need to ignore the y for now because I got to use what I have. I can see that these are vertical angles, so they must be equal to each other. So 18y plus 5 must be equal to 10x minus 61. However, I can't use that right now because I can't solve an equation with two different variables. So let me see if there's a relationship between these two expressions. There is, because they're on a straight line together. So they are supplementary. They're a linear pair. So 10x minus 61 should add with x plus 10 to equal 180 because these are supplementary. These are vertical angles. So I've identified my two relationships. I've set up two equations. I got to solve for x before I can solve this. Okay, so I've got to do this one first. So I'm going to combine like terms. I get 11x and I get minus 51. And then I'm going to add 51 to both sides. I get 11x equals 231. And then if I divide by 11, x is 21. I found x. I still have to find y. So I'm going to go over here, and I'm going to plug my new x in. So I found that x is 21. So now that I've found x and I've plugged it in, I can now solve this equation because there's only one variable in it. So I got 18y plus 5 equals 210 minus 61. That gives me 149. And then I'm going to subtract 5. Get 144. And then I'm going to finally divide by 18, and I get that y equals 8. So I've now solved for my x and my y. Okay, if you need to stop and go back and take your time and look at all of this, go for it. This is a tougher problem, but you will see it in the future. All right, hope you guys have a great day.